Quick sound check. Very good. Good morning, everyone. Do we need music or something? No one comes to lecture. It's kind of sad. What would make this more fun? Oh man. For those of you watching online, come to lecture. Could be fun. Which will probably be me next year watching online. All right. Let's get started. I keep running behind, so I'm gonna try to stay on pace today, which means you do need to stop me and ask questions. I will probably pause a little less often because we basically have to finish grouping, pivots, and joins all of that today. So this is going to be a big lecture where we're sort of wrapping up every piece of the table operation you need to kind of make progress throughout the semester. We're going to bring in more as we go, but like the main pieces are finishing up today. Okay, so some exciting announcements. Let me spotlight this. spotlight for everyone. Here, so you guys can see me. Okay. Homework 4 is out. It's due Wednesday, 2/14 at 11 p.m. Project 1 is being released today. The first checkpoint for project 1 is due. So projects are 2-week assignments, but we have a checkpoint 1 week out. So to make sure you don't fall behind, I will say I've been in classes. We don't do that. It's a disaster because everyone tries to do 2 weeks of work in one night. So checkpoint next Friday, and then the final submission the following Friday. This is a cool project that's playing with a data set, thinking about populations. I think in lab or discussion, you'll see a really cool video. It's based on a neat TED talk. So a lot of fun stuff in this project. Midterm accommodations form will be released on Monday and is due Saturday, the 25th. So if you have issues or need accommodations for your midterm, please fill that form out as soon as possible. Questions? Yes. What time will the question? I don't know. What time is project 1 being released? Sometime today. Sometime today. Noon would be great. If the TAs are watching, maybe we can release it soon. Okay, yeah, so project 1 will hopefully be out very soon today. Okay, other exciting news. This semester, we're going to try to have rough grade bins. In other classes, we found that it really reduces stress to know what you're at least guaranteed to get. So these are the rough cutoffs. Historically, this class has generally given relatively high grades, and I believe that's because people learn the material. These are the bins that we've used historically as well. So an A range is 90 above, B range is 80 above, C range is 65 and above. We will adjust the pluses and minuses as the semester goes, and maybe if we can get some more clarity after the midterm, we can release more details about pluses and minuses. We won't increase these cutoffs, which means if you all do super well in the midterm and everyone gets an A in this class, that's what happens. We might have to lower the cutoffs. If the midterm just doesn't go so well, or people start to have trouble, we can lower these bounds so people, essentially your grades can go up. Questions about grades? All right, so that's the end of logistics. Let's get into some new material. So one of the things you use often in Python, we kind of avoided up until this point in the course, is a list. And so I'm going to take a little bit of a detour from our tables and the arrays that we've been using in the past to introduce a new concept. So lists are generic sequences. They can contain things of many different types. They're kind of like an array. They are a sequence, and we can pull individual elements out. But they, again, can contain things of many different types. So here's a list. It's got a number, some text, even has a column. Actually, sorry, it has a table, whole table inside of a list. Okay. We're introducing lists because one of the ways we'll work with tables is sometimes we'll want to add rows. So far, we've been attaching columns to the side of our table. Because a column is always the same type, everything the same type, it's an array. But a row might have things of different types because it has multiple columns in it. And so we need a way to express things of different types. Demo time. All right. So I'm also trying to post the empty version of my notebook online for those who want to try to do the exercise with me. And I've been putting the solutions when I have a cell where I'm going to fill in class. Don't look at the solution, try to work through it first. But if you want to follow along, you can download or go to the empty version from the course website. All right, so standard imports. Let's start with some lists. So here's a simple list. The first piece of new syntax for you is these square brackets. So a list is just a collection of things separated by commas with a beginning square bracket and ending square bracket. That's one list. Here's another list. Here I'm assigning it to a variable. So again, beginning square bracket, ending square bracket, another list. Okay, so we've got two lists. Not that complicated. Pretty similar to our arrays. recall we made an array using make array, and then that was a function, so beginning parentheses, and then a bunch of things we want in the array. And again, with the array, everything was essentially forced to be the same type. Even if it wasn't, we'd find a type where it all made sense. A list, everything can be different types, and we want that. So again, this list here has a number, it has a string. It didn't force everything to one type. All right, so here's some questions. What's another list? So actually, I should explain my syntax here. So I have a list. This is my variable up here. The other use of these square brackets we've talked about in the past as a way to pull elements out of something. It's called indexing. In previous lectures, we did something like myArray.item to pull the second element out of the array. We also showed you that you could use square brackets to index into an array. Lists, you can only use square brackets. So if I want to get the second element from this list, what do? What's this going to return? This is going to return 1, 5. Hello. Who says 1? Who says 5? Who says hello? Excellent. Hello to you. Let's try. Yeah, so it returns hello. All right, let's try something a little bit trickier. What's the next thing going to return? What's this going to return here? A little bigger. Right here. What's this going to do? Think through it. Here's how to read it. My list. I'm going to get the fifth element from the list. Got it? So remember, starting at 0, so we count. So fifth element in my list is 1, 2, 3. It's kind of like computer scientist. 0, 1, 2, 3, 4. So that's the 4 indexed 4 thing, fifth element. So that, let's just do this first. That returned an array. But since the thing that this returns is an array, I can say take 1, and that's going to return what? B. Got it? Any questions? New concept. It's good to have questions. All right. So I said we introduced list as a way to combine things of different types and preserve their types. So now let's use that for tables. So again, we've been building tables like this. So actually, I guess we've been building tables. I have a blank table I added with the column numbers. And I guess previously we've been doing something like make array because we didn't want to bring those spooky square brackets in. Okay, but that's a lot of characters. And people would go, that's too much typing. I'm okay with just making that a list. The library, the tools we use will automatically convert that back into an array. So save you some typing. You want to put a few things into a column, you could use a list. It will force it into an array of a single type. So we've taught you with columns. We didn't talk much about this thing here. So this thing here just made a blank table, right? Let's make an example here. So if I just type table, that's a blank table. Well, we could have given it an argument. In fact, we can give it a list. It has to be a list. And this could be the list of names for the columns. So let's run it. There's our table. It's an empty table, but now at least the columns have names. So it's an empty table of 3 columns, no rows. Now let's put some data in a table. So this, what is this? So I said drinks, which is an empty table, but it has column names. And I want to have these rows with these rows. And here's a list. So I have a list of lists. Okay, that kind of makes sense. Each row is going to be an element to my list. And then each row itself is a list of things. So my first row is milk tea from Asha. Who's been to Asha? You haven't? Check it out. It's very good. Enjoy Asha. Big fan of boba. So is my daughter. All right. So there's my drinks. I made a table by giving it a list of rows, each row being a list of things. Questions? Yeah. Yes. So throughout this class, we've been doing with columns, then I make array for the drinks, and with columns, I make an array for the cafe, and then with columns, I make an array for the price. That's totally reasonable. This is another way to do it. All right, let's move on. Return to slides. Okay. You have to give myself instructions so I don't get lost. All right, we just did this, rows from lists. Okay, review grouping. Let's do that. All right, so we started grouping. Grouping is a pretty powerful concept in data science broadly and how we work with data, because we often take aggregates, combine our data to get summaries. And so we walk through this grouping operation. Basic idea of group is I'm going to take a table. I'm going to tell you some column or columns that I want to group. And that's going to say, take that big table and slice it into groups, where within each group, for the column or columns I have chosen, it is all the same value. Got it? So I've chosen just this column, which I didn't label. Should probably fix that. And I said group on that column, so it split the table into groups. Right, but group's not quite done yet. I then need to apply some operation, because when I'm done grouping, I'm going to get one row for each of these groups. I only get one row for each group. So I have some function that's going to combine the information from that entire sub table into a single row. The default operation is just going to return a single value, which is the count, the number of rows in that little table, that subtable. But you won't be using the default operation in many cases. You'll get to define your own. When you define your own operation, it's applied to each column in the subtable. So for this subtable here, I applied the min operation. I took the min of this column, I get one number. Take the min of this column, I get another number. And so I'll get this row in my final output table. I do that for all the other subtables. Good? Questions? Yes. Yeah, so how do you use your own function? Great question. We're about to do that. Okay. Other questions? Yeah, what if the column is a column of strings and the function makes no sense? Also a great question. Let's go do that. So maybe to short answer, we can build our own functions. And if it makes no sense, the library goes, great, that makes no sense. I will leave it blank. So you try to apply an operation that doesn't make sense for a column, you just get a blank in that entry. Okay. Wait, I'm supposed to do a demo. Let's do a demo. All right. So this is where I was supposed to go yesterday. We're going to look at the welcome survey. So this is the survey you all filled out. And we're going to study a few things about this. So the first thing I want to study is I'm going to group by year. I want to know how many people are in each year. It's going to be kind of fun. There we go. So what do we see here? First year is a lot of first year students, a lot of second year students. This survey was optional, so it's not the whole class. There might be a selection bias. I suspect as you go further in your studies, you respond to fewer and fewer surveys. Fourth year students, fewer. Graduate students, good job. 7 graduate students, big fan of the PhD program. Okay, so that was a simple group operation. What happened? I grouped by the year column, took all the unique values. There aren't that many unique values here. And for each of those subtables, the default thing was to count the number of rows in those subtables. That's what I got. Let's do something more fun. So how much are you all sleeping? Apparently, actually, let's see. Okay, so I want to take, I want to compute the average, yes, the average amount of sleep for each year. So let's do this in steps. Okay, so I'm going to give myself some parentheses so I can make this couple lines. So I have my survey. So I'm interested in the year, and I'm interested in hours of sleep. So sleep. Okay, so that's the little table I want to look at, kind of clean stuff up. All right, so now let's do a group. I want to group by year, and this time I'm interested in the average, right? So I could do NumPy's mean or average. It's in the slides I wrote average. Okay, so now I'm going to get the average. That's cool. But that's really hard to see. Remember I said, like, looking at a table, you can't really see trends. You can't see patterns. Or you can if you're really good at it. I can't. So we're going to make this a bar chart. Actually, let's just put an extra column in to see what happens. Put something meaningless in. What's meaningless? Pets. They're not meaningless, but what happens if I try to take the average of pets? Yeah, that column doesn't make sense, so it's blank. Got it? All right, so let's go back here. So this was neat, but can't visualize it. So let's make a bar chart. I don't want to take the bar chart of the year. Cool. Do you see any trends? Maybe. Fifth year above are not sleeping well. Actually, no one's sleeping well. You should be sleeping more over here. One of the things we mentioned in visualization is it's good to rearrange your columns so they make sense, or your bars. These bars are in some weird order. So let's use one more operation here. So I'm going to take all of the rows, but I'm going to take them in a different order so that the result makes more sense. So what should be the first thing here? This is number 2 in this list. So it's 1, this is 0, 1. So I want first year to go first. 0, 1, 2, 3, 4, second year. Third year is 5, good. That's the last one on the list. What do I need yet now? Fourth year? What do I need? 2? Yeah. And then I need fifth year and above, and then I want, where are the graduate students? 0, 1, 2, 3. Good. Okay. So now I rearrange my bars, get a nice ordering. All right, so I showed how to select, group, take, and I made a bar chart. And the conclusion is, you start out not sleeping, maybe it's partying, then you're like, learn how to sleep, and you start taking more classes, and then you stop sleeping, and then you become a graduate student. And graduate students get to sleep. Grad school is awesome. Okay, let's see. By the way, so I have the solutions here, so if you were trying to follow along, you can click and see the solution. And check me. All right, so the next thing that's more fun is extroversion. It's a number. We asked you to rate your extroversion on a scale of 0 to 10. Is that a categorical variable or numerical? So this is a number because it's going to matter what it means and so on. But I can still group on it. And so because you're forced to use an integer, you can't have fractional extroversion. It can make sense to group. So let's go ahead and group and see what's going on with extroversion. Okay. So I want to compute the average number of texts, hours of sleep, and piercings for each value of extroversion. And I want to save the result in by extra. Okay, so how should I do that? So I'm going to do survey, group. What do I want? I want to group by extroversion. Okay. Let's just see what the output looks like. So by the way, what I'm going to do here is how I tend to do this myself. Sometimes I'll think through my steps and I'll just keep running it and kind of revising the cell until it kind of makes sense. So I got the counts. That's pretty close to this bar chart up here. But I wanted some specific columns. So let's break this into steps. I want extroversion. Keep that. I want number of textees. I assume these are people you text. Hours of sleep. Piercings. Okay. So group by extroversion. What did I do wrong here? Well, I want average, right? So I said I want the average. So remember, I didn't say an argument for how to compute things, so it didn't really change anything. But now if I say pi.average, there we go, the average counts. What? All right, someone has too many piercings. Yeah, let's not look at piercings. All right, so I've collected averages. So I took all the students that took the survey, grouped them into their specific choice of extroversion, took these columns, and then took the average of their values. Questions? No questions. Cool. All right, so let's start to play some plots. I've pre-computed these. Let's see what it looks like. I have a bug. Okay, so I have a bug. I know what my bug is. This is an important point of grouping. So I'll scroll down to the bottom. It goes, number of textees mean is not in my table. No, what do you mean it's not in my table? I took the mean. Aha. So when I choose a function for my grouping operation, the library is smart enough to go ahead and give you labels for your columns so you don't get confused. This is not number of textees, it's number of textees average, right? Now, in my code, I had assumed here I would type mean. Now it says number of textees mean. And now my plotting function, which is looking at the extroversion as a function of number of textees mean, will work. So we can see trends now in our data. And these would be hard to see if I didn't do this grouping, right? So computing these summaries for each of these groups of extroversion makes it easier to see the trends in my data. Sort of like that windowing calculation we did on Wednesday, right? Something more interesting. Do extroverts sleep? I do not know what that trend means at all. So if you're kind of mediocre, mid-tier extroversion, you don't sleep as much. But if you, there's no trends here. Okay, so that wasn't as interesting. Probably no strong relationship between extroversion and hours of sleep. Questions here? This is unfortunately still all review of stuff that we covered on Wednesday. Okay. Now for the fun stuff. Okay, so we did grouping. So in summary, the group method can be used to aggregate rows that share the same combination of the values in the columns that I've chosen to group on. The first argument is a list of columns which to group by. So I had to put a list. I only used one column so far. In a moment, I will use multiple columns to group. The collect operation determines, which is optional, determines how to combine the values in each of the remaining columns that I didn't group on. And it's applied to one column at a time. So we can group on one column. You can also group on two columns. And I think I'm supposed to show you that now too. All right, so we've been grouping on one column. Now let's do two columns. And then we get to do some pivoting. All right, so grouping on two columns. Now, suppose, oh no, don't look. It's close. Okay. Suppose I wanted to group both handedness and sleep position. I think there's this adage that, depending on which hand is your dominant hand, you sleep maybe on the opposite side of your body. So we have both these variables in our survey. So let's see. I want to know group count. So I'm going to use a default argument. How many people are in each combination of handedness and sleep position? Survey. I'm going to group list. I want a list of handedness and sleep position. Is that going to work? Let's try it. Cool. Okay, so I got groups. Now each of the groups shared the same handedness and sleep position, and those little tables just two rows in it, right? Another table, ambidextrous and on left side, had 4 rows in it. Got it? So grouping on two things. I don't like that it's not showing me everything. It's kind of annoying. There's a way to fix that. So if I go over here and I say show, that's just going to show me everything. Got it? Did I get it right? I did. Good job. Okay. Does it matter what order I do these in? Okay, so a few things that are worth noting here. It changed the order of my table, right? So it gets to pick the order of these groups, and it's going to sort on the first and then sort on the second. So if I flip it, is it going to change the answer? It still has the same values. It's the same collections of little tables, the same collection of groups. The order in which they're presented in this table will be different, the sort order, but it is the same data. Everyone get that? Okay. All right, let's do something more interesting. So we can take the same exercise as before. Just copy it down here, save some time. All right, and now I want to compute most sleep on average. All right, so I want to compute the average sleep. Let's just do np.average. See what happens here. Oh man. Okay, so too many columns. How am I going to fix that? I could just select afterwards. It wouldn't really matter. Let's maybe do that. I want sleep position. I want handedness. And I want what? What did I want? Hours of sleep. Sleep. Is this going to work? No. Why not? Remember, average, because I named this average here. These two columns were grouped, so they don't get changed. Their column names stay the same. But this one, because I said average, I have to say average here. Now we're good. That's confusing to me, so I will just put this before. Will that work? No, why? Because I haven't averaged yet, so I'll put it like that. Okay. Pause for a second. Yeah. Yeah, okay. Why are there brackets? Yes, the brackets are back. I have a list. One thing you might have been wondering, maybe throughout this class, is this select function, sometimes it has one argument, 2 arguments, 3 arguments. In fact, it can have as many arguments as it wants. It's going to treat those essentially as a list internally. So when we built the select function, we didn't want you to have to write square brackets everywhere. Grouping is a little bit funny because the first thing, this is actually 1 argument. So the first thing it wants has to be a list. It can actually be an array. You could have written array. It needs to be a sequence of things. This would also work, but that's a lot of characters. And so in Python, and if you go out in the real world, everyone will do this. They say, I have to give you a list. The arguments to this function need to be a list. The first argument needs to be a list of 1 or more things. All right. If it's one thing, we're like, this is one of the beauties of Python. I can cut this out. It's going to be okay with that. I kept that position in, but make it a list. You will see, and probably in the exam, if you have one thing, you do not need to make a list. So the right way to write this would be like that. Okay. But if I have 2 things, let's just try to do it. I write handedness. It goes, I can't average by handedness that this is not a mathematical function. The second argument has to be a thing that I can apply to columns. Handedness, I can't do that. So I need to make this whole thing as my first argument. That's my first argument. Questions? Yeah. Yeah, so are arrays and lists interchangeable? In many cases, they are. I'm going to say something that's, again, a little out of scope this class, but it's funny. In Python, there's this concept of something called duck typing. The types of things are ducks. And it's actually, it comes from the statement, if it walks like a duck and quacks like a duck, then it must be a duck. So what Python will do is if the thing kind of works, if I can get into it, I can access elements, I'll just go ahead and take it. So many cases where something can take an array, it can also take a list. Because if it just works, if it does what it needs it to do, it'll just go, yeah, I'm cool with that. So in most cases, you can probably mix the two. But in practice, if you have a column, an array is the right way to think about it. And certainly when you ask for a column from a table, it will not give you a list. It'll always be an array. Okay. What did I break? I forget what I broke. Fixed. Good. Okay. So one of the things that I don't like about this is it's hard to see what's going on. And so you see, have all these combinations and they're like, is there any trends or relationships between handedness, sleep position? There's another way to deal with grouping that we will use very commonly in data science. In fact, it sort of made spreadsheets popular for certain kinds of analysis, and that is the pivot table. Let me show you what pivot does. Okay, so here's the code I had above, and it made this kind of messy looking table. Messy in that I have all these combinations, and I kind of might want instead to have my columns to be on your back, on your left side, on your right side, and on your stomach. Maybe my rows correspond to these values, and then the cells in this table should be the counts. So I just want to rearrange this data so it's just easier to look at as a table. So I'm going to give you another operation. It does exactly the same calculations, but it arranges the data a little bit different. Try to not make bugs as I write this. Okay, so this is what I had before. Now I'm going to write a different way to express this. Survey here, and I'm going to say pivot. So pivot, new operation. You just heard it. And I'm going to pivot on handedness. me just show you what this looks like first, and I'll explain the arguments in a second. I'm going to pivot. The second argument is going to be sleep position. Third argument is going to be hours of sleep, because that's the thing I want to calculate. And the last argument is going to be NP.average. What did I do wrong? Hour of sleep. Hours of sleep. Okay. So I've just rearranged this table up here into a table here. It's the same data, but arranged in a way that's easier to read. So let me explain what happened here. So I want to group on handedness and sleep position. That's what I just did with this new function. But instead of making a bunch of rows with different values for handedness and sleep position, it's instead said the first thing will become the columns of my new table. All the values in handedness will be a column. So ambidextrous, left-handed, and right-handed are my columns. The rows of my table will correspond to sleep positions. So on your back, on your left side, on your right side, on your stomach. And the values of my table will be based on hours of sleep, that column, taking the average for each of these combinations, right? So I'll build the ambidextrous on your back table, and then I will take the average of hours of sleep, and I will put that number in this cell. And I'll do that for all combinations of each of these values. And that last part's important, for all combinations. So all the unique values of the handedness column and all the unique values of the sleep position column, I will put an entry in this table. And if it's missing, I'll put a default entry where it could be 0, an empty string, depending on what operation you use to aggregate that one remaining column. All right, so I want to just walk that once more. In Python, I can name each of my arguments. It has to be the arguments, the names have to correspond to the names of the variables in that function, the arguments of that function. So I'm just exactly the same thing as above. I just writing out for full clarity. So pivot, first argument is the columns, and I have to choose what I want to make my columns. In this case, the unique values of the original handedness column in my survey. The rows correspond to the unique values of the sleep position. So that's going to be over here on the left side. And the values are going to be hours of sleep, and I want to compute the average for each of those hours of sleep. Really useful function when you're doing analysis. Easier to see your data this way. Okay, just as with pivot, if I don't give it all of these extra arguments, these values and how to collect them, what's it going to do? Count. So same as before, same as group, but now pivot. So now arranged in a way that's a little bit easier to see. What's kind of cool about pivot is our plotting libraries will plot a different bar for each of the columns. Right? So if I say pivot on sleep position and handedness, and then construct a bar chart using just the handedness, I'll get separate columns for each of these. So you'll see what it looks like in a second. So now I have a pretty cool visualization for what's going on. So I can say, look, if you're ambidextrous, we're looking at counts. There aren't many ambidextrous people, so we can't really see what's going on here. If we wanted to, we might want to restrict our attention to that. But let's look at left-handed and right-handed. So left-handed people sleep on their right side, and right-handed people seem to sleep on their right side. In fact, these trends look pretty similar. You see? So now I can start to compare for any one of the rows what the values for each of the columns were. Got it? All right, questions? Okay, keep going. Turn to slides. Turn to slides. Okay. I don't know what these bears mean. These are in the slides every year. I assume this is bears that are pivoting, but someone can explain it to me or post on Ed. All right, pivot. So groups according to 2 columns. That's important. So if you want to group by 1 column, you can't use a pivot. If you want to group by 2 columns, you can use a pivot. If you want to group by 3 columns, can't really use a pivot. Must be 2 columns. It produces a grid of counts or the aggregate values. There are 2 required arguments. The first determines what will be the columns of your table. The second determines what will be the rows of your table. You get 2 optional arguments. The third, which will be the thing that you're going to compute on, and the fourth, which will be the thing you're going to apply to each of those subtables to compute a single cell in your new table. And I did a demo, so I'm not going to go do that now. So when should you use group and when should you use pivot? In the real world, pivot's actually not a function in a lot of tools. And people complain about that. So you're forced to use group and then do stuff, with spreadsheets afterwards, which is why people like spreadsheets. Pivot in some tools is available, and so then you have a choice. And so which one should you use? Certainly in our libraries, you'll have a choice to do that. So when should you group? If you have one categorical or one variable you're grouping on, you can't pivot, so one means you should group. If you're constructing aggregates of many, more than two, you are forced to group. If you have many output values in the aggregate column, or sorry, this is two answers. So if you have multiple output values, if I'm trying to compute two things that I'm aggregating, I only get one cell to store the answer in a pivot, so I have to use a group. And I'll actually do this with an exercise at the end of lecture. All right, so when should you pivot? Actually, one other reason you might want to use a group, which I didn't list here, is if you have way too many columns, right? So if there are like thousands and thousands of unique values that you're trying to turn to columns, it's just kind of hard to work with. So typically then you consider using a group. When to pivot? So again, exactly two variables, that's pretty important. Few unique values for the column variable. That's what I just said a moment ago. And you're interested in every combination of values. Because remember, the group is just going to consider it's only going to return rows that correspond to combinations that you do actually have. Whereas pivot, there's going to be a cell for every possible combination. Questions? This is confusing stuff. So I'm totally reasonable to have questions right now. Yeah. So what does the few unique values for a column variable mean? So remember, I get to pick the first argument to pivot is what I'm going to use for column. And if my column is going to be cities in the world, that's my column, then I'm going to end up with a table which has thousands of columns. And that's kind of just hard to work with. And I would go like, well, I'm interested in columns where it's a city, like I can't filter columns that way. I can filter rows with the predicates, but I can't columns. So in that case, I should use a group so I can say then, where cities and then look at certain conditions on cities. Let's keep going. Group or pivot. Join. Now this one makes sense. These two bears are joining on column 1 and column 2. Well, that'll make sense in a second. All right. So joining is the last big idea. If you ever work with database technology or database people, this is their life. This is the core technology in a lot of data systems. It's going to seem a little bit simple now, but you'll see. Okay. So join is basically I have two tables and I want to bring them together around something. So far, you've been doing things where I take a column from one table and I just stick it on the other table, right? But in this example, I have the drinks. But again, check out Asha. So drinks from my local cafes, and I have discounts. I can't just take the coupon discount and just stick it on the drinks table. Doesn't make sense. First of all, it's not the same number of rows. Second of all, maybe Asha lines up, Strata lines up, but this would be giving me the Asha discount for Strata. That's not right. So I need to connect these two tables. And the way I'm going to do that is with a join. So join takes the first table, drinks, and I want to join it with the discounts table. And I need a set of arguments. The first argument is going to say, on what column do I want to match across these two tables? So in this case, I want to match the drinks column, the drinks table with the cafe column. And I want to match the discounts table on the location column. Okay. And that's going to produce a new table. And how is this table built? So let's go through the steps. All right, so match rows in this table. So let's walk down this table. I'll try to do this as an example. So the way this works is I'll walk down each row in this table and I'll go, okay, so for this row on the cafe column, is there a matching column in the location table? Okay. Yes, there's two. So for this one, I'll take Asha, it matches Asha, and I'll get a new row in this output table, which contains Asha, which was the cafe, so reordered a little bit. The drink was milk tea. The price was 5.5. And the location was Asha again. So I'm going to drop the location column because it's going to match the cafe. And then the coupon was 10%. Done. But there's another row. So I'm going to keep checking. All right, so milk tea, Asha, matches this one too. So I'm going to take this row and combine it with this row, and I'll get Asha, milk tea, 5.5, and then 5% in my coupon column. So connecting the rows that match in one table with the rows that match in another table, and they're matching on the cafe and location columns. How about espresso strata? All right, so this is a little bit confusing. The output is sorted, so it's going to sort cafe. So the next thing that it's going to produce is FSM. So it's going to go to this column next. Actually, yeah, let's do that. So it's going to go to this column next, or sorry, this row next. So it sorts first cafe and did Asha. Then it's going to go for FSM and it's going to go, okay, FSM, location. Uh-oh. There's no corresponding row in the location table for FSM. Bummer. We're just going to skip that. So if there isn't a match across the two tables, the row is lost. And if I had another row here that was location Nefeli, it didn't have a match here, so it's not going to get to go to this other table. Okay. So you have to have a match in both tables. All right, so we keep going down the list. We did FSM, so now we'll go to espresso strata. There's a match here. There's one match, 25%. So we'll do strata espresso 1.75 is here, and then 25% over here. Do you see that? Yeah. Great question. When joining these two tables, is there a way to find all these lost rows? Unfortunately, the tools that we're using in this class aren't going to keep that information. We could do extra analysis to see which rows matched using intersections and stuff we'll probably cover later in the class, but we haven't given you the tools yet to answer that question. I won't say any more. Yeah. Other questions? I keep building this out. If you have questions, let me know. Okay, so again, the first argument is the column in my first table that I want to match. The second argument is the second table that I want to join to. And the third argument is the column in the second table that I want to match the column, the first argument in the first table. Okay. So cafe should match location. And then I want to take drinks and join it with discounts. So arguments. Okay. Yeah. Yeah, so for every row here, every match will generate a new row in this other table. So you can have many matches. Yep. That's okay. You'll have to deal with it in your analysis. You might group, perhaps, to collect it down to one value. Maybe take the min if you want the best discount. Yeah. Does join update the drinks table? Great question. So the drinks table, in fact, just as a theme in this class, we don't change the table. We always produce a new table. So all the operations that we've covered in this class will take tables. This takes two tables, drinks and discounts, and produces an entirely new table. Drinks remains, drinks. That's actually a philosophy in data science that we try not to change our data. We produce new data. We try not to modify the data that we have. Okay, gonna keep moving. All right, other highlights. So the resulting table is gonna have the column here, cafe, it'll always be the first column, plus all the columns you had in the first table, plus all the columns you had in the second table, minus the column you joined on. Because having cafe and location having the exact same values would be silly. You know that location will always match cafe. Other questions? Okay. In the slides, if you're watching online, I've highlighted this walkthrough that I just did pointing with my mouse. Okay. The join column, time for demo. All right, so drinks, it's my drinks from before, discounts just from the slides. Let's join them. So we just saw this in the slides. We'll go ahead and write it again. I want to do anything interesting. No, I don't. Okay. So I'm going to take my combined table and say drinks dot join. I'm joining on cafe. And I want to join that with the discounts table. Well, let's see, if I do that, it doesn't work. It doesn't work because I didn't say how to join, because discounts doesn't have a column cafe. It's per location. There we go. Combine, let's see what that looks like. And that produces a table we saw on the slide. Okay. All right, so let's do something interesting. I want to calculate the lowest price you can get for each drink using the available coupons. Here we go. All right, so how am I going to do that? Let's first, we got our combined table. Let's look at it there. We have the coupon, percent off. Let's do something here. I need the discounted fraction. Oop. Do it here. So I want the discounted fraction. This is how much I'm going to get. If I want a thing I can multiply by the price to figure out how much it's going to cost me. This would be 1 minus the combined table column. And then I have coupon percent off. Okay. This is a number that's between, this is a percent, so let's divide by 100. Okay, good. That's my discount fraction. All right. Don't need the period there. All right, so now let's take our combined table, which I could build again here. I've already done the join, so I'm saving myself an extra step here. And I want the with column. So I want to compute the percent off. So I need the discounted price for each of these drinks. So with column, I want the discounted price. And I'm going to take the combined column. So my combined table price, that's this column here. And I want to multiply it by my discount fraction. Okay, that's my discounted price. Now, how am I going to get the cheapest price for each of the drinks? How would I do that? Cheapest price for each of the drinks. Because remember, I got multiple values because this join had all the possible combinations. So I'm going to do group by drink. Cheapest price? No, I need something else, right? I want to take the discounted price that I just computed, price, and I want to take the min. That's not going to work either, right? What am I doing wrong? I want drinks, min. Okay, that's my min price. Problem is I'm taking the min of the other column, so let's do one extra select statement here. Dot select, and I want drink, and I want discounted price. There you go. So I've computed the discounted price for each of the drinks, the lowest price I could have gotten for each of the drinks. I have 1 more minute. Maybe let's go through this, and then next week at the very beginning, we'll try one of the or two of these discussion questions. I think they're good exercise. All right, so this join is interesting because I got to join a table with itself, and you're going to see all possible combinations of the drinks joined with drinks on cafe. And so you can see now I'm taking essentially the product of all the possible values. So for each row in here, I'm going to match itself in the subsequent table. Okay, all right. Let's stop here. On Monday, we'll go through 2 exercises, combine, group, and join.